Hello and welcome to the Daily Space for today, March 12th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today is a day filled with news, mostly of the past. What's amazing about astronomy and space science is it has the ability not to just tell us where the universe is going, not just how things are evolving, but to also look back and help us understand what has happened in the past, including our own Earth's past. And today, that is where a lot of our stories come from. In our first story, we have a tale of an overly active sun. Some of you may have heard that back in 1956, the sun let off a coronal mass ejection aimed towards the planet Earth that was detected all over the planet, caused amazing aurora, northern lights, southern lights, and had it happened today, would have done extraordinarily bad things to the network of satellites that orbit our world. Our understanding that our sun is capable of doing these things on a recurring basis is part of the reason that space weather is the developing field that it is. By positioning spacecrafts out at the gravitational balancing point between the sun and the Earth, the Lagrange 1 point, we're able to, have a line of defense between us and the sun. Spacecraft that we stick at that location are capable of measuring the high energy particle events that come from the sun, get to the spacecraft before they get to us, and then send back at the speed of light radio information, that the storm is coming. This allows us to put our spacecrafts into safe modes, to get our astronauts into safer places as needed. Now, the thing is, it turns out that 1956 event, while the most powerful ever measured in the 70 years that we've been measuring these kinds of events, it is not the most powerful of these solar, photon storms that has ever occurred. Using a combination of different data, including both looking at tree rings and looking in ice cores from Greenland, scientists have now determined that in 660 BCE, before the Common Era, there was an event that was 10 times stronger than the 1956 event. This is the kind of event that, were it to happen today, saving our spacecraft might not quite be enough. So our sun has, within recorded history, been able to throw out massive particle storms. Now, what we don't have at this time is any archaeological evidence that the auroras that would have been associated with this were observed and recorded. I, for one, look forward to the historians looking to this scientific data that uses carbon-14 radioisotope dating in tree rings, as well as looking at other isotopes in the ice cores to determine exactly when this happened. Now that we know the science, the trick is to find out, were people looking? This is one of those remarkable multi-study kinds of studies that are possible. We have examples of this with supernova events, with Halley's Comet, with other celestial events that have made their way into history. There's a rather famous Polish painting that I will tweet out later today of a jester in the Polish royal court sitting looking forlornly with a window behind him that shows a bright comet in the distance. And this was the night before a massive war was set to start. So even in our artwork, we see evidence of actual, scientific events that did happen. Now, in addition to understanding things that have occurred in the imaginable history, we have things that happened unimaginably long ago. In this case, I'm starting to talk about numbers as large as 40 million, which for the cosmos is a blink of the eye. But for humanity is, oh, we weren't around quite yet. And here what I'm talking about is the history of the Tibetan Plateau. The Tibetan Plateau is a vast, fairly flat landscape at an elevation of about 4.5 kilometers. Often referred to as the ceiling of the world, this high plateau is known for its nomadic people, its amazing vistas and landscapes, being a place where great herds still roam with their herdsmen. Well, geologically speaking, this part of the world is one of our largest and youngest upliftings. The Tibetan Plateau, as well as the Himalayas, only started to form roughly 55 to 60 million years ago as the Indian plate, that big crustal plate of land that now forms India, slammed in to the Asian plate. When this occurred, the two plates crashed, lifted up, forming the Himalayas. In addition to forming the Himalayas, a whole series of different bits of bedrock lifted up to form this Tibetan Plateau. Now, it had long been thought that this entire plateau may have lifted up at once and in the process radically changed the weather patterns for that part of the world. It's because of the Himalayas and the Tibetan Plateau that we have the monsoons that we currently see in Southeast Asia. These lifted up landscapes actually steer the moisture, steer the storms, and actually also dried out, well, the deserts of China. So it's because of the Himalayas and Tibet that we have the weather we have today. Well, in looking at the fossil record, in looking at a variety of different other features within the landscape, including looking at the radioisotopes in the landscape, scientists have now begun to think it didn't all rise up at once, but rather piece by piece over time, and was also shaped by the wind and that weather. So in this case, we have the uprising landscape shapes the weather, but the upraised landscape was shaped by the weather. The flattening that we see is in part due to the winds that race across this plateau. So today is a day where geophysics, astronomy, and earth science all combine to help us understand our own planet Earth a little bit better. And that concludes today's news. Now, I do want to remind you, oh, actually, sorry, I lied. I have one more news story that I almost left out. Now, one of the news stories that we very rarely cover is such and such a scientist has been awarded this, has been given the opportunity to do that, this telescope is being built. And part of the reason that we don't tend to cover those is we wait for the science results to come out. We wait for the telescope to actually have first light successfully. Well, in this case, I'm going to bring up a result simply because I didn't even know this was still possible. So scientist Darby Dyer, who has joint appointments at the University of Arizona and at my own institution, the Planetary Science Institute, which in the name of full disclosure is one of the producers of this show. Well, Darby Dyer, she got awarded the opportunity to study some pristine glass beads that were gathered by the Apollo missions back in the late 60s and early 70s. These pristine samples have not been studied at any point before. One of the things that I didn't know, and the reason I'm bringing this up, is the scientists back in the 70s took the time to say, future technology is going to be better than what we have today. Let's set aside some of these rocks to be studied someday in the future. What makes that particular decision particularly prescient is those scientists didn't have any way of knowing that it would be more than 50 years from that first step on the moon until we return to the moon. We don't know, in fact, is it going to be 60 years? Is it going to be 70 years? We don't know next when we're going to be bringing back samples from our nearest satellite. So what she's getting to do, exploring these stored away scraps of the moon using new technology, is going to be our first new look at the lunar surface in my lifetime in a lot of ways. I mean, other people have looked at dust, other people have looked at rocks, but this is a very special case. So kudos for the permission to get to do this. To read a quote from the press release, the spectroscopy consortium addressing redox acquired by beads. So SCARAB is the name of this process. SCARAB will use tiny glass beads found in the lunar soil to turn the moon inside out, Dyer said. We will study the interior processes that led to volcanism on the lunar surface. We will use state-of-the-art synchrotron technology and a mapping FTIR spectrometer to measure gradients of volatiles, hydrogen and oxygen, preserved in lunar glass beads. So this is volcanic glass in the form of beads that was created in lunar volcanoes, gathered by Apollo 15, 16, and 17 astronauts, brought back to Earth, and stored away until 2019. So I, for one, absolutely cannot wait to see this research. And that actually does conclude today's science, but I do want to remind you, we will be taking any of you who want to come, and unfortunately who have the money to come, out to Joshua Tree National Park this summer. You have the opportunity to join me, Fraser Cain, Skylius, John Matt Gautier, Paul Matt Sutter on one of the most beautiful landscapes in California. This is Joshua Tree National Park. The Joshua trees are rare and getting more rare every year. The skies here are dark, but we're losing dark skies more every year. So come with me. You, yes, you out there, come with me to Joshua Tree National Park. And let's enjoy those dark skies. And let's enjoy those Joshua trees while they're here to be seen and experienced. The costs have been reduced. The registration dates have been extended. So if you looked before and thought, I can't afford this, well, take a look again. So the URL to go to is astrotours.co/all. Starstrider will get you there. So if June in California isn't your thing, we also have a trip through the American Southwest, originating in Tucson, Arizona, and traveling up through Las Vegas. So lots of different things. This one is astrotours.co/starstrider. So 2 trips, 2 URLs, 2 opportunities to go out and explore the night with yours truly. And that concludes our primary show for today, and I will now start taking your questions. And when you type them in, I'm just going to remind you, please, please, please remember to @Starstrider. It makes it a whole lot easier for me to find your questions. While you're typing those questions in, I'm going to do a brief station identification. My name is Dr. Pamela Gay, and I am here to put science in your brain most Mondays through Fridays, right here on the Daily Space at 1 p.m. Eastern. That is 10 a.m. Pacific, and currently at a very confusing time if you're in the United Kingdom or anywhere other than America and Canada, because we do daylight savings time at weird times. I apologize. You're on your own right now. So join us, but tomorrow it's not going to be me, it's going to be Annie Wilson bringing you updates on spacecraft and space news. In addition to the Daily Space, we bring you the Sunday Science Hour with Annie Wilson and a whole variety of launches, landings, and other special events from astronomy and space science. This Thursday, we will be doing live coverage directly following the Daily Space of the launch of the next crew to the International Space Station on board a Soyuz capsule. So tune in Thursday and stay for the extra bonus features after the show. We are a part of CosmoQuest. Check out cosmoquest.org. We are your place to learn and do science. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are here thanks to the generous donations of people like you. Thank you for all that you have given. You, your subscriptions, your donations, your bits, they make the science flow. So thank you. And now I will take your questions. So Larry Weird and Proud is asking, how are your eyeballs today? So for those of you who don't know, I scratched my cornea. Don't do this, people. I didn't mean to. I woke up with something in my eyeball, and in the moments of waking up with something like in my eye, I was like, rub, 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 rub. Don't do that. I know not to do that, but when you first wake up, you have no rational brain. At least I have no rational brain. And I managed to, whatever it was that got in my eyeball, move it in an oval across my cornea, creating a scratch that makes all point sources of light look just like the diamond ring effect of a solar eclipse. And I understand the science of why this is happening, and it is deeply psychologically disturbing for everything to look like it does in the moments leading up to an eclipse. And it hurts. And I have been grouchy pants this week about it, and have canceled some of my streams on my personal channel. I am still grouchy pants about it, and I don't know how long this will take to heal. And I'm sad, and I'm grouchy pants. So yeah, don't do this, people. I did go see a doctor. The doctor said it would take a week to heal. So hopefully by Thursday I will be fine. And if not, I'm going back to the doctor. So yeah, don't do it. I feel like I am a cautionary tale for something, and I'm not sure what. And while I understand the science of what's going on, I kind of wish I didn't. Okay, scrolling backwards to look for sciencey questions. Yes, this is Stella, and she is failing to dog bed. Eddie is in here. He's just at my feet instead of over by her. So Henny's Warverp is asking, do solar storms have any effect on the atmosphere that could be studied later? There's actually a lot of people who study solar interactions with the atmosphere in real time. There are various stations that do this at hugely northern latitudes. I'm trying to remember the name of the city in Sweden where they have sounding rockets launched to study this. So this is the kind of thing that gets studied in real time, and it's pretty awesome. One of the best resources to go and just day to day keep up with this stuff is spaceweather.com. And it is space weather. And yes, that was 6 monitors. That was a picture of Darby Dyer while she was working up at Argonne National Lab. So Henny's Reverb asked, is Mars weather affected by Olympus Mons or the Valles Marineris? Yes. I don't know the details, but yes, geological features like this do affect weather patterns. So Veronica Cure asks, how much time do the satellites at L1 give us about incoming solar storms? It depends on just how fast the particles are moving. The thing about coronal mass ejections is not all of them are the same, and the same is true of solar flares and other outbursts that the sun makes. The particles coming out of these high energy events are all coming at slightly different velocities. So some of them, they give us minutes of warning because we have high energy particles like electrons that don't weigh very much, moving at significant fractions of the speed of light. And the sun is only 8 light minutes away. And sometimes they give us hours of warning. But we're pretty good at safetying things quickly as needed. And yes, welcome Bombardie. Bombaddi? I'm not sure how to say your name. You are welcome here. So Mike Cassidy asks, are lunar volcanoes caused by meteor strikes or when the moon still had a molten interior, or both? The meteors themselves were caused by when the moon still had molten interior. But the breccia, the formerly melted rock on the surface of the moon, in some cases was caused by impacts, and in some cases by impacts like digging down into the molten stuff and letting it ooze out. So you can look at the moon and find shield volcanoes and related lava tubes. You can also look at the moon and just see these vast seas. Thank you, Lancy, for the bits. There, go. I have such sleepy dogs. So for those of you who are new, when there are donations, the dogs get Cheerios. This is consistent across both me and Annie Wilson, who's our other streamer on this channel. So thank you so much. Okay, scrolling down to see what else we have. Down with daylight savings time. I agree. There's actually lots of science saying that daylight savings time is terrible for humans and the economy. Mike Cassidy just writes, launch? Yes, on Thursday there's currently a Russian launch planned to carry 2 astronauts up to the International Space, or 3 astronauts up to the International Space Station. Enjoy your dinner, Astro B. Yeah, Mike Cassidy. So the thing that I had explained to me is that while I might want to wear an eye patch because my eye hurts less if I keep it closed, eye patches are actually really good at trapping in moisture and causing infections, so don't do that. Oh, thank you, Susie, for announcing that. So thank you also for the sub. Hey, Stella. Eddie. Sit. There. Trying to get a better camera angle at the dogs. Thank you so much for the sub. So yeah, I found out I am the 2019 recipient of the Isaac Asimov Science Award that is given out by the American Humanitarian Association. And I am super pleased and will be attending the award ceremony in Pittsburgh. So I don't know who nominated me, and I'm very grateful for that anonymous stranger. So thank you. Okay. Yay, life is good. Do we have any other questions? Any other questions? So tomorrow it will be Annie Wilson here. She has been working on some amazing space science kinds of stories. I'm trying to get Eddie to look at the camera. Eddie, what's this? So he says thank you. He just doesn't know he says thank you. And pardon my arm as I cut it off with the green screen. There. Bonus bonus treats for the dogs. Thank you all. Thank you for just being supportive. And that is an emote I have never seen, Muhala. What is that? Party popper. That is cool. I have not seen that before. So thank you all for being here, and tune in to see Annie tomorrow. And I am going to roll the credits and look for somebody to raid. Now, the place that I always go to find other science and education streamers is the Knowledge Fellowship. This Discord is your place to go find out, well, who all is here trying to educate you on Twitch. So check it out if you haven't already, and let's keep the learning going. Wherever you are in the world, have a fabulous morning, evening, or afternoon, and remember to look up. Bye-bye.